Everybody, welcome back to Chem Talks. Mr. J here. Today we're going to be talking about one of the most powerful tools that we use in chemistry, and that's called dimensional analysis. Maybe you've heard this as factor labeling or unit conversion, but this is a tool that we use in chemistry all the time. Not only is it used in chemistry, but it's used in life, right? Maybe a good example is if you have $1, how many quarters is that? How many nickels? How many pennies? That's all dimensional analysis is changing the units that we use, right? It doesn't matter if I have 100 pennies or $1 bill, I have the same amount of money. We just express it in different ways. And dimensional analysis allows us to move between different units. So let's go ahead and talk about this and how we do this. Once you've learned how to do this in chemistry, you can apply it to many other classes as well. Okay, so all dimensional analysis really is about is converting units. Often we measure things in one unit, but maybe the problem asks us to express it in a different manner. For example, if we want to measure the different distance from Loveland to Denver, we're probably going to do that in miles, but maybe it doesn't want to know in miles in the question. Maybe it asks in feet or kilometers or meters. Okay, so because it's most convenient for us to measure in miles, we're going to measure it in miles, and then we will change it to whatever unit we need to later. That's what converting units allows us to do. Okay, all it is, dimensional analysis, is simply a method for changing our units. It doesn't change the overall value, right? $1 and 100 pennies have the same value, it just changes how we express them. Okay, dimensional analysis is important because units are constantly needed to be converted in chemistry. Maybe I tell you I have 6 gold atoms. Well, that doesn't really do us any good, right? If I want to measure out, I use grams. Am I going to be able to measure the weight of 6 gold atoms here in class? No, but maybe if I had 6.02 times 10 to the 23rd gold atoms, which is called a mole, I can measure that out. That would be a much better unit to use. The other place that's going to come really into play is our next unit, which is on stoichiometry. Stoichiometry just looks at the relationships between reactants and products. So for example, let's say we're talking about the combustion of methane. Methane combines with oxygen to produce carbon dioxide and water. If I start with 3 liters of methane, how many liters, how many milliliters, how many grams, how many atoms of, molecules of water can I produce? So those are all examples that we're going to be looking at as we move forward in this. So dimensional analysis is a really important tool in science, not only in chemistry, but physics uses it well. In physics, if you know dimensional analysis really good, if you know what your answer is supposed to be, you can often work the problem backwards and figure out how to set it up. So there's one big principle behind this. And the idea of dimensional analysis is that you can multiply anything by 1 and you still get the same. Okay? It's not going to change the physical meaning of the measurement, right? But it will change how we express that. So for example, we can say if we take 27 inches and we multiply it by 1, we're still going to make 27 inches. Our goal is to create these factors here that allow us to basically multiply by 1. We call those factors equivalents, okay? Or the other term you'll hear with this is conversion factors. They mean the same thing. I use both of them, okay? And a conversion factor is just 2 things that are numerically equal, 2 measurements that are numerically equal. 1 yard is 3 feet. 1 foot is 12 inches. 1,000 meters equals a kilometer. 1 meter is 100 centimeters. Those are all equivalencies. Okay? So here's a couple we just said. 1 foot is 12 inches. 1 dozen is 12. If I have a dozen eggs, I have 12 eggs. Okay? 1 kilometer is equal to 1,000 meters. These are all equivalency. Now we may say them differently, right? But a dozen eggs is still 12 eggs. It's the same physical amount of them. And that's what conversion factors or equality and dimensional analysis takes advantage of. So let's look what happens when we put these on top of each other. Let's say we have 1 foot and 12 inches, right? They're the same. They're that far apart, right? So we can say when we put them on top, they're going to cancel out and they equal to 1. So this is like in the previous slide where we took 27 and multiplied it by 1. Okay? We're trying to set up these conversion factors. Okay? When you put 2 things that are equal to each other, physically equal to each other on them, they cancel out to give us 1. But what this does allow us to do is change from 1 unit, miles, to another unit, feet or inches or whatever we want to change it into. So let's take a look at this. We have this line of some length, right? We can measure this in inches, okay? Or we can use a metric ruler and measure, let's say, millimeters, okay? That's it. If we do this, what we see is we're going to create an equivalency here. There's where we're measuring. So we can say that 10 inches is equal to about, I think, it's 254 millimeters. I just created a conversion factor, or equivalency, to convert between inches and millimeters. Now, we'd probably usually end up doing is we come down here at 1, and we compare everything to 1 something. 1 kilometer is equal to 1,000 meters, or 1 inch here is equal to what, about 35 milliliters, so about 46 millimeters, somewhere in there. I don't have my glasses on, sorry. But we can create these equivalencies. And we can write these equivalencies two ways. Let's take our kilometers one. We know that 1 kilometer is equal to 1,000 meters. Okay, we can write this as a fraction, which is how we write these equivalencies. And there's 2 ways we can set this up. We can put 1,000 meters over 1 kilometer, or we can say 1 kilometer is equal to 1,000 meters. Doesn't matter, they're the same distance. The big question comes in then is, which one of these do I want to use? Which conversion factor? And the answer is based on what your question is asking for. What answer do they want? If your question says, I have 10 kilometers, I want to know how many meters that is, what we're going to do is we're going to use the conversion factor that has the units that you're looking for on top. So if I give me 10,000 kilometers, I want to know meters, I'm going to use this one. Or if they want to say at 1,500 meters, how many kilometers, I'm going to use this second one. So that's all. That's how we choose which version that we're going to use on this. And the dimensional analysis takes advantage of canceling. You've probably done canceling in math where you've had kind of long fractional problems and you look at the number on top and the same number is on the bottom, or something can be divisible by is on bottom. We cancel this out. Well, same thing happens when we do dimensional analysis, okay? But what we start doing, we look to set it up so that our units cancel. If our units cancel, then it sets our numbers up to multiply and divide correctly. So let's take a look at this. Let's say I have 24 inches and I want to change this to feet. Well, what factor do we know about feet and inches? Well, we know that 1 foot is equal to 12 inches. Okay, but I want to go to feet, so I want to get rid of inches. So I'm going to put my 12 inches on bottom and my 1 foot on top. This is my equivalency, my conversion factor. Now, whatever is on top and bottom can cancel each other out. So in this case, my inches are going to cancel each other out. Now, once I've canceled out my units, I can also see if any of the numbers cancel out. So my inches are canceled out. Look, but I see that 12 was in a 24 twice, right? So I can simplify that. Now, if you have a calculator, I probably wouldn't worry about this step, okay? You can just easily throw the numbers in the calculator and get an answer, okay? But if you're doing mental math, this would be a good way to do once you get your units canceled. Now, canceling units is mandatory, okay? Canceling the numbers with a calculator may save you a little bit of time or may mess you up. So don't worry about canceling the units if you have a calculator, but do have to cancel out your units. And then I'm left with, here at the end, my unit. My last box here at the top should always be the units that I'm looking for. All right, let's talk about how we do the math in these. So as we go across, our problems are set up like division problems or like fractions. So you have a top and bottom. As we go across, we're going to multiply across the top or the bottom, okay? We're going to multiply across the row, and then I'm going to divide the top by the bottom just like you would as a fraction. So if we have, as we go across, we're going to multiply this times this times this. We'll do the same for the bottom. Okay, and then we can multiply. Once we get an answer here, we can divide the top by bottom. Now, remember, with multiplication division, order of operation doesn't matter. So I could take this times this divided by this times this divided by this. It doesn't matter. But the general idea is you multiply the top and the bottom numbers, and then you divide the top by the bottom. Okay, so let's look at this example. If I wanted to convert weeks into hours, I know that I start with 2 weeks. I know that in 1 week there are 7 days. I want to get rid of days, so I'm going to put something about 1 day there are 24 hours. So here, first thing I do is check to make sure my units cancel. I do. The only thing left with is hours, which is what the problem wants. Now, I can look really quick to see, do any of my numbers cancel? Well, the bottoms are just ones, okay, so nothing's really going to cancel. So I'm going to take 2 times 7 times 24, divide that by 1 times 1. Now, on a calculator, I know this is going to be 1, so I'm not going to worry about it, but I wanted to show you what we are doing here. Let's look at the steps for setting up dimensional problems. 6-step process, which you're going to end up doing without even thinking about the steps. But the first thing you want to do is you want to write down the given information. What numbers do they give you in a problem? What are they trying to get to? That's important, what units they get to. And then what information do you already know? What are conversion units? I know that 12 inches is 1 foot. 100 centimeters is 1 meter. Those are things that I should write down because they're going to help us create our dimensional analysis. Second thing then is you're going to create this conversion chart. You'll sometimes hear me refer to as a ping pong table. Okay, that's the line that has both the vertical and horizontal lines to set it up. Once we have that, we're going to write our given in the first box. Your first box is always given. And what I'm being given, it's given to you in the problem. Okay. Then what you're going to do is you're going to start putting in your conversion factors. Okay. So you're going to take the conversions that you figured out in this first step and put those in the box. Now, eventually we're going to get to the point where we can say, oh, this is a 3-step conversion problem. This is a 4-step conversion problem. By steps, I mean boxes. Our first box is always given, and then we'll have as many conversion boxes as we need as we go along. Once we have this set up, okay, we're going to cancel all units from the top and bottom. This time you could also cancel your numbers if you want, but if you're using a calculator, don't worry about it because in step 6, we're actually going to use our calculator to do the answer. My one suggestion here is make sure you're entering your numbers into your calculator properly, that you're not accidentally putting the wrong number or hitting a multiplication sign when you mean a plus sign or something like that. Okay? So be careful. Okay. So let's look at a simple problem. If we want to convert 25 kilometers to meters, first thing I see, this is my given right here, 25 kilometers. Okay, I want to find meters, so in the end I should end up with meters. Well, what do I know already? Well, I know my relationship between kilometers and meters. I know that 1 kilometer is equal to 1,000 meters, or 1,000 meters is equal to a kilometer. I can write it either way, right? Which way am I going to write? That depends on my answer. They want meters. So I want for my conversion to be a meter because this is going to be a 2-box problem because there's a direct connection between kilometers and meters. So I set up my table. Okay. This is our picket fence. So first box, I'm going to put in my given unit, which is going to be the 25 kilometers, and then I'm going to do my conversion unit, right? And we said we want meters, so we're going to use this one on the left. Okay, so let me set this up here. All right, so when I do this, guys, if I'm doing this in a Word document for a lab report, something like this, I'll use the insert table to make this easier to do rather than hand drawing them. And then I kind of hide some of the, I can teach you how to do that if you want. So first box is my given. I'm going to have my conversion factor, and then my want is my answer. So let's start with my given, 25 kilometers. I want to get to meters, and I want to get rid of kilometers. So I want meters on top, kilometers on the bottom, and I know that 1 kilometer is equal to 1,000 meters. My kilometers end up canceling out. All I'm left with is meters. Okay? And now mathematically, what I'm going to do is to take 25 kilometers times 1,000, which gives me 25,000, right? My meters, my units here have canceled out. I'm left with meters. Let's try another one of these. Let's go from meters to centimeters. In this case, I know my given 1.5 meters. Okay, my units, my answer is going to be centimeters. And what do I know? Well, I know that 1 meter is equal to 100 centimeters. Okay, there is a direct correlation between these. Okay, I don't need to do any further steps, so I'm going to have a 2-box problem. Once again, I start with my given. I'm going to my conversion factor and find my answer or my want. So I start with 1.5 meters. Now, which way am I going to write it? 1 meter over 100 centimeters or 100 centimeters over 1 meter? Well, what I want goes on top. So 100 centimeters goes on top and 1 meter goes on the bottom. And now I check my units. Meters cancel out. All I'm left with is 100 centimeters. Mathematically, I'm going to take 1.5 times 100 divided by 1. So I get 150 centimeters. Okay. All my units except the one I want cancels out. All right, try this one on your own. How many days have you been alive? So take whatever year you are. Don't worry about point whatever. You're 15, 16, 17 years old. Convert those into days. Go ahead and pause, and then when you're ready, come on back. So I'm not sure how old you are, but let's say we're going to let your years be X, right? And we know that in 1 year has 365 days, okay? So this is a direct relationship between days and years. So this is a two-box problem. I start with your given, your years. Let's say it's X years, okay? And now I want to go to days. So days on top, years on the bottom. So I know 1 year is 365 days. And to multiply, I'm going to take your years times 365 and divide it by 1. Okay, our years cancel, all we're left with is days. So there's our math. So pretty simple. Hopefully these are coming together. Now, I could make this a little more difficult. I could say, how many weeks are you? Okay. Well, we know that 1 year is 52 weeks. That's pretty easy. Or what about hours or minutes or seconds? For those, we would have to make additional boxes so we don't have to think too much, okay? We do our thinking in our boxes, okay? Let's say if I wanted to get to hours, I could do one more box where I know that in 1 day I have 24 hours. So I could do that. All right, let's try this. Let's try a two-box problem. Convert 25 kilometers to centimeters. Now, I want to use the conversions we've already done. If you know metric well, you can figure out easily how to convert from kilometers to centimeters, but there's moving decimals and zeros, stuff like that. So let's do this the easy way. Let's start with the two conversions I know. 1,000 meters is 1 kilometer, and 100 centimeters is 1 meter. So I'm going to need to use two conversions plus my given. That means this is going to be a 3-box problem. Now, if you're not sure how many box problem this is to start with, just make your first box, and then you can add as you go down. So I start with my given. I want to get rid of my given. I want to get rid of my kilometers. So 1 kilometer is equal to 1,000 meters. Okay. What do you think goes in the next box here? Right? It's meters, centimeters. I want to get rid of meters. So 1 meter is equal to 100 centimeters. Okay, so like I pointed out earlier, we're usually comparing these to 1. Now, when we get into stoichiometry, that's going to change a little bit because we're using our balance equation. But for now, it's going to be that. Okay, our final units here are centimeters. So mathematically, I'm going to take 25 times 100 times 1,000 centimeters because this was the only unit that didn't cancel out. And then I divide it by 1 times 1. And I get 2.5 centimeters. So not too bad. Okay. See if you can try this one. This is a little variation of the one I just talked about. If you are 3,500 weeks old, how many years is that? Go ahead and pause this and then come back to me when you are ready. All right, here we go. So what do I know? I know that there's 52 weeks in a year. We're going to make this a little bit easier here. So if I'm 3,500 weeks, okay, and then I can change, I know that in 1 year, there are 52 weeks, right? But which one do I want on top? I want to get rid of weeks. So weeks is going to go on the bottom, and I'm comparing that to 1 year. Okay, there we go. So my weeks cancel out. I'm left with my unit a year. Now, mathematically, what I have to do, I'm going to take 3,500 times 1 year. That's our only unit left. Divided by 52, and you're 67.31 years old. Okay? So the bottom is not always going to be 1, but you're generally, in this unit at least, comparing something to 1. When we get into stoichiometry, that's going to change just a little bit. All right. So take a look at this. Take a look and tell me what I set up wrong here. Which step is incorrect? Okay, you don't even have to know them. Looking, what units cancel, what don't. If you look, it's right off the bat, right? I'm starting with days, and it looks like I'm going to go to seconds here. So I want to get rid of days. I need to have days on the bottom. So this right here is inverted, right? If you mess this step up, there's a good chance you're going to mess the rest of them. In this case, I didn't, okay? But this one I did. So what it really should look like is this. 1 day is 24 hours. Okay? It's really easy if you do this correctly. If I would have followed along, oh, I want to get rid of days. Oh, 1 day, 24 hours. It's really easy to get off. So make sure you set your conversions up in the correct order. You want your units to cancel. All right, try this one. This is a bit of a tricky one. If you're 18 years old, how many seconds of this? Take it step by step. Go ahead and pause and come back and see me once you're done. Did you pause or are you just slacking? Get your paper out, write it down, get your calculator. If you don't have your calculator, it's okay. At least set this up. All right, let's look at what we know. Okay, our given is 18 years old. Let's look at the conversion factors. We know 1 year is 365 days. You got 10 days. We know that 1 day is 24 hours. 1 hour is 60 minutes. And then 1 minute is 60 seconds. So I have 1, 2, 3, 4 conversion factors here, plus my given. That's going to be a 5-box problem. Now, if you don't know that off the top of your head, that's fine. Just start with your given and leave yourself plenty of room. So I'm going to start with my given, 18 years old. Okay. Now I want to get rid of years, and I want to go to my next one is days. So 1 year is 365 days. Now I go to the next one. 1 day is 24 hours. Get rid of this. Now 1 hour is 60 minutes. And 1 minute is 60 seconds. If I look here, hopefully all my units that will off there will cancel each other out, and I'm left with 60 seconds in the end. Now, mathematically, look, at the bottom's going to be 1. That's easy. Now, I take 18 times 365 times 24 times 60 times 60 gives me 567,648,000 seconds. That's a big number. If we get a number like that, what we're probably going to end up doing is write in scientific notation. We'll talk a little bit more about this in class. We've already have, but remember, scientific notation is one number, then your decimal places, then times 10 to the something. The something represents our placeholder. So we always go to 2 decimal places. So this is going to be 5.67. Look to the right, it's a 6. Bump it up. So 5.68. And how many places after decimal? 1, 2, 3, 4, 5, 6, 7, 8. So 5.68 times 10 to the 8th second. We'll work on that in class. Okay, remember though, this is really important. Every number needs a unit. We do not have naked numbers. I've been talking about that all year, but this is really important in dimensional analysis because the units need to cancel out. If you are missing units on numbers in this, you're going to lose points because I need to be able to see how things are converting, how they're changing from one to the other. You go to college, take chemistry. This is going to be it. You do physics, you're going to need the units. Okay, so no naked numbers. Remember that. Okay, if you do have naked numbers, weird stuff like this happens. Take a look. Doesn't make a whole lot of sense, right? All right, guys, that's an introduction to dimensional analysis. I hope you understand the idea of it. It's just converting one unit to another. The physical amount isn't changing, but how we express it. We're not going to measure our distance up to Cheyenne in inches, right? Maybe we're going to measure it in miles. We can take those miles, convert it to yards, yards to feet, feet to inches, okay? Or we're going to go from miles to feet to inches, something like that. It's just a tool that lets us convert. In this unit, we're going to be looking at converting between the number of particles into the number of moles. If we have a given number of moles, how many grams is that? How many liters is that? So this is going to serve as the foundation of everything we do for the rest of the semester. If you're feeling a little lost now, don't worry about it. We'll work on it in class. Otherwise, guys, if you have any questions, please come see me before class. Otherwise, have a great day. We'll talk to you soon.